Hello, my name is Michael Kimmich. I'm a second-year electrical engineering student at Clark Community College. Today is June 9th, 2017, spring quarter, and this is my SOP presentation. My SOP presentation was a continuation of a last year project, which was the EDbot, which is used in Engineering 270 and is programmed in assembly language. What I did with my project is I took that same concept and made it a lot smaller, but instead of using the PIC 18F1220, which was used on the original EDbot, I moved over to the APAGA 328 because it's also used in the Arduino environment. The reason why I went over to Arduino is because it's a lot easier to program and it's a lot more user-friendly. It's programmed in C, and it has a pretty big open source community, so it's user-friendly. And it's a great place to start for any introductory student for computer science, electrical engineering, or hobby stuff. So I built mine oriented to like intro students or hobby enthusiasts. That's pretty much what I did. The way I solved my problem, or the way I ended up in my latest prototype, is originally I started with testing the motors. The original motors are DC 5-volt DC motors. So if I want to make it smaller, I move to these pager motors. So my first prototypes was just testing the motors, and I have just little dip switches directly to the motors, and if you see, it worked pretty well. So after I did these motors, I tested these motors, I went on to my first prototype using the microcontroller, which is right here, my V2. And what I learned from this prototype is that I couldn't run it off only 3 volts. So then I tried to stack 3 volts on top of each other for 6 volts. And I learned that although this would work, the RBG LED speaker and everything else would work, it would not work while running the motors themselves. So then after that, we moved to the motor driver and other stuff to solve that problem. And this is my latest prototype, the V4. And here we have pretty much the same stuff as the V3. We have a speaker, RGB LED, some buttons. But on this version, we added some IR proximity sensors and object avoidance. We added a IR receiver for remote control and a USB, a mini USB that could connect directly to your computer, and it could be downloaded or programmed just like an Arduino. So this is basically an Arduino on wheels with some other toys. What I learned from this is that it's a lot of work. And I'll just demonstrate what I have so far. So these are 2 V4s, and this is just a demonstration of the RGB LED. You have red, blue, green, and then you can mix the colors to make white. Another demonstration is of the speakers, and then the motors. This might run off the table. Or not. So yeah, it works pretty well. This is not the final product. In the next product, next prototype, I want to add a gyroscope, and then circuit protection for the battery and recharging the circuit. So yeah, it works pretty well so far, and that's pretty it.